All right, so I apologize about the screen looking a little off. I just kind of moved my capture over a little so that we can get a little more of the decimals when we're going in and doing that. So now we're looking at transformations of cubic functions, right? And so if we're looking at that, you know, we got this +3 and this -4. So if what we did earlier is any indication, this should move it to the left 3, and it should move it down 4. So it should put my vertex here. Let's see if that's the case though. All right, so let's put that in and see if that's actually what happens. And then for the second one here, we got a negative, so maybe that means maybe it'll flip it, right? And 2 means it's going to make it larger, right? And then again, our movements with changing the inflection point on this, so that point between the two parts of the graph. Remember, the cubic functions are generally functions that hit everything. Okay, so let's take a look. Let's see what happens. So here is our first one right here. So I'm gonna toggle it and turn it on. And sure enough, right, it does look like it went over 3 units to the left and it went down 4 units. And there's our inflection point right here at the points -3, -4, which you can pull right off of this. And other than that, it's a pretty standard cubic function, right? Kind of opens sort of slow, right? And or opens quick, but then it slows down in a hurry and gets really big. All right, so now let's plot that. So we're going to go over this way 3, and then we'll go down about what would be 4. Right here, like and so we are going to take this and go like this. Apologize for any interruption, and it kind of goes like this, and then it starts to open up, and then eventually it's gonna, you know, cross the x-axis, right? But these things, like we said, these things open slow. All right, they do not open quickly at all. And yeah, that's just kind of the property of them. And so let's mark our inflection point right here. We're going to call that -3, -4. I'm not sure if that's the mathematical term for it, but that's what I'm going to call it. And so the cool thing about this one is our domain and our range don't change from our parent cubic function. Remember, our parent cubic function is just this, right? That's our parent function. Probably should have mentioned that earlier, but hoping that you kind of figured that out, right? And so our domain is going to be x, and then for all x, it's all real numbers. There's no x values that are not affected by this graph. And then y, it's the same thing. It's going to be, you know, all numbers, right? So all reals, and then close it off, all right? And so hopefully for this one, we'll see that it's going to be the same deal with our domain and range, right? And that's kind of easy to remember. We like that. And let's see if our predictions about this negative, and see if it opens up and makes it a little bigger and flips it, and let's see if we're right about that. Okay, so let's go to Desmos. We'll toggle this off, and we'll toggle this one on. Yeah, and sure enough, it shifted it to the right one. It took it up 3. There's our inflection point right there at the 0.13, and it flipped it, right? It turned it the other way. And it's now twice as big, right? So after 1, it grows 2 instead of 1, right? And then that's how it's going to work. It's still not going to grow super fast, right? But it will grow quicker. All right. So let's get our point. So we have the 0.1, -1, +3 off this. So that's gonna be our inflection point. And then this time it's going to, you know, kind of go like this, and then it's going to come down quickly, and then it's going to go sort of like that. All right. I don't like how I drew this end here, right? Well, we're going to fix that a little bit. So we'll have this kind of open a little slower like that, right? So let's mark our inflection point right here. We're going to call that 1,3, and our domain is going to be the same. Our domain and range are going to be the same as the previous one, because these cubic functions are all inclusive and don't shut anybody out, unlike the square root functions, which are kind of fussy. So hope this is helpful to you guys. Good luck with these. Not super difficult. Just the big things you're looking for are negative, positive shift here, and then what is happening under the radical, moves it left or right, and then outside of the radical, any adding or subtracting is also going to move it left or right depending on it, right? So that's kind of what you're looking for. That's what you're going to clue in on when you look at these, and that should kind of give you an indication of what it's going to be. All right, so good luck with these, and good luck with the homework.